Hey guys, it's me, Miss Mills, and welcome to Mrs. Mills Math Time. This will be the very last video you have to watch this week. Guys, I'm sorry I bombarded you with a bunch of videos, but I really want to help y'all out, and I'm hoping that these videos help with the explanations and with all of the examples that I'm giving you. The whole point of this video is to help you out with converting a standard number to scientific notation, and that's what we're going to be doing today. So this is going to directly help you out with your scientific notation worksheet that I am making you do on Thursday. Okay, so I will be pulling examples directly from that worksheet. So if you watch this video and you will probably get some answers to a worksheet that you have to do this week. So I'd highly recommend taking notes during this. But let's go ahead and get started. Um, the very first question that I'm going to pull from the worksheet is going to be number 1, just because I like to be easy. Okay, and we're going to start with 21. Here is our number. It's a really, really small number, but again, like, you can turn any number into scientific notation, any number in the world. Okay, um, I would just highly recommend it with taking really, really big numbers and turning it into scientific notation, or really, really, really small numbers and turning them into scientific notation. But you also do need to know that you can take a simple number like 21 and turn it into scientific notation as well. And let me teach you how to do that real quick. So the very first step is we have to locate the decimal. And on this part, it's going to be always right behind the number. Okay. And what we're going to do here is we're going to take that decimal, we're going to move it to the left one time, because the whole point of moving the decimal is to get just one number on the left side of the decimal. So I would move this decimal to the left one time. Okay? So once I do that, the number turns into 2.1, right? Okay? And then we're going to multiply that by 10. And then how many times we move the decimal number or the decimal over is how many exponents we're going to have. In this case, it's going to be 1. And since we move the decimal to the left, it is going to be a positive exponent. So remember that if you move it to the left, it will always be positive. Okay? All right. So let me do another example of one of these. So this is when you have a really, really big number. So let's go to number 17. In this case, it's going to be 17, and then we're going to have 4 zeros behind that. 4 zeros behind it. Okay? So again, first step is locating the decimal. The decimal's right behind it. Okay? And we want to move the decimal to where there's only one number on the left side of that decimal. So we're going to move it 1, 2, 3, 4, and 5 times. So our new number is going to be 1.7. Okay? And then we're going to multiply that by 10. And then we're going to count the decimals. We moved it 1, 2, 3, 4, 5. So our exponent is going to be 5. And since again we moved it to the left, it's going to be a positive exponent. Okay? If you have any more questions with taking really, really big numbers and turning it into scientific notation, remember to contact me and I will help you out. But let's now move on to really, really small numbers. Okay? Because in those cases, your exponents are always going to be negative, and let me show you why. Let's go to my first example. I decided on number 12. All right, so let's go to number 12. In this case, it's going to be a small number, so we're going to have 0.00042. We want to turn this into scientific notation. Okay? So we have to first locate the decimal. It's already here for us. It's right here. Okay? And then again, we want to move the decimal to where there's only one number on the left side of that decimal. So let's go ahead and do that. We're going to move it 1, 2, 3, 4 times. Okay? 1, 2, 3, 4 times. So then our number is going to be 4 decimal 2. And we're going to multiply that number by 10. And then how many times did we move it again? We moved it 4 times, so our exponent is going to be 4. But wait a second. Remember how I said if you move the decimal to the left, it's going to be positive? Well, it's going to be the opposite if you move the decimal to the right. If you move the decimal to the right, your exponent is always going to be negative. You moved it to the right negative, so it's going to be, or right, you moved it to the right 4 places, so the exponent is going to be -4. So every time you have a really, really small number and you want to turn it into scientific notation, remember to make sure that the exponent is negative, okay? All right, let me do one more example of this then. Let's move on to, I don't know, number 16. Let's go to number 16. So we have 0.041. I'm going to make that decimal a little bit bigger. There we go. And we want to turn this into scientific notation. So again, we want to first locate that decimal. That bad boy's right here. And we want to move it to where there's only one number on the left side of that decimal. Okay? So let's move it. 1, 2. Okay? So now our number is going to be 4.1. Okay? Again, we move the decimal 2 times. So we're going to multiply this by 10, and then we're going to put a 2 as the exponent because we moved it 2 times. But remember, this was a small number that we turned into scientific notation, and we moved the decimal to the right. So the exponent will be negative. Okay? Guys, I hope this helps you out with the scientific notation worksheet. You will be doing this Thursday. I hope y'all had a wonderful day. Remember, it's a beautiful day, and I miss y'all so much. You have no idea. I can't wait to see y'all again next week. See you guys. Bye.